Hey everybody. So back to my question from yesterday about the electromagnetic cannon that my son showed you. I think everyone in the comments posted really good ideas that they thought he was actually getting a bit of a shock at the end, and that's why he said ow. And I thought it'd be an interesting thing to show you what's really going on at the end of that as he kind of levitates the pieces of aluminum on the electromagnet. So in order to verify what's going on, I'm actually going to need to show you a infrared thermometer here, where what I can do is I'm going to take a reading in degrees Celsius. First on these, if I just shine the little laser at that aluminum, I can see that it is 25.5 degrees Celsius, let's say. The other one is a little bit colder, 24.4 degrees Celsius. So we have a pretty good reading on those to start with. Now, here's the interesting thing that happens. As you saw in the video yesterday, if we turn this on, it'll shoot the aluminum up into the air. But the thing that happened at the end of the video is levitating this above the magnetic field. It's interesting to try to figure out what's happening because aluminum is not actually magnetic. Aluminum doesn't get influenced by a magnetic field in the normal way that iron would, where it would be attracted or repelled. But what aluminum does is a little bit different. Aluminum is a really good conductor of electricity. And we're going to find that aluminum, being a really good conductor of electricity, will end up having the electricity, the electrons, go around this loop of aluminum. Whenever you put aluminum in the presence of a magnetic field, especially a strong magnetic field, the electrons are going to start to flow, and it develops a current of electricity going around inside the aluminum, and that's what we're going to be looking at today. Now, to bring it back to what we learned about circuits, though, and why my son said ow, is because there's no resistance, really, in this aluminum. There are no light bulbs, there are no resistors, and so those electrons can just freely flow around the aluminum very, very quickly, creating a lot of current going through this. But you can see, touching this, I'm not getting shocked. But the interesting thing that happens is if we look again at the temperature, you see that now our temperature is 32 degrees Celsius. And I think it's even going to rise higher than that. If we put this down close, that's starting to get very, very hot. If I can get a good reading here, 38, 40 degrees. We're getting up in the neighborhood of about 40 degrees Celsius, a very big temperature change just because of the electricity going through there. So I'm not getting shocked. It's actually very, very hot.